So I said we have the architectural drawing already. So this is a story building, the ground floor, the first floor, and then the roof. So like I said, I'm trying to repeat myself, that the first assignment is to understand the architecture. What's the problem that you're supposed to solve? If you don't have an understanding of the problem that you're supposed to solve, it doesn't make sense for you to even start in the first place. So you look into your project, understand the demand of your professionalism, and then from there you can start to create a solution. So this is the first floor, and then the roof plan. Good. But I've done the general arrangement drawing. So I have this for the first floor, I have it for the ground floor. The reason why you are seeing this is because I designed this structure originally for raft foundation. But in our own case here, I said we're going to be doing the pad foundation first. When we're done, we're going to do the raft foundation. When we're done with that, we're going to do the pile foundation so that you can have understanding of all foundation types. So having said that, I've done the GA. After this class, after this section, I'll send you the AutoCAD files for the architectural drawing so that you can make your own general arrangement drawing and continue the modeling from there. So that if you have any question, we come back to the next class and solve solve that problem or those problems, whatever the case may be. Now look at it now. The next thing I want to do is to go to a ProtaStructure and start the work. Okay. So like what I said, you should know, I already said previously, after you must have done everything you want to do on your page, on your AutoCAD page with the architecture, you want to convert to DXL file so that you can import to ProtaStructure. You know what I'm saying? Come here, save as, then you find the DXL file. All right, give it a name, save it. So once you're done saving, you can close it because you're going to be using that file on ProtaStructure. Yes. So we're good. Now that I've closed it. So we'll look for a ProtaStructure. And it's already opened, but this is a project I'm currently working on. So I'll have to close it so that we can focus on our own tutorial. So I'll save this and then we'll create a new project. So we can call this tutorial. Then I have projects that have the template as a template. I want to use my previous project, the settings for my previous project for this new project. So I'll just find one of these drawings that I actually want. So, and I use the OK. So I have a new project. This is a fresh project. So the first thing I want to do here is to import my DXF file, the one that I just did, the GA I just did. If you're doing a GA, fine. If you're having a picture representation on your AutoCAD, fine. Whatever it is, just for you to import that to ProtaStructure. So you go to building setout. I hope you can see my ProtaStructure. You go to building,
Yes.
then external reference drawings. Once you use the external reference drawings, you click add. Once you click add, you go to pardon me, You go to the folder where you kept the drawing, all right, and you click the drawing. This is the approval drawing, and that's it. Automatically, it loads it into the story reference drawing. So let's wait to see. So as you can see, it has been uploaded or the import is complete. I used OK. Now look at it. What I need. This is exactly what I need. Other ones I don't really know that one. This is exactly what I need. Okay. There's a way we import with grid lines, but just to save you the stress, sometimes it imports correctly, sometimes it gives you double work. But it's better for you to just have a guide to whatever you want to do in ProtaStructure. Then you move on from there. All right, so let me put the grid lines that comes with the architecture so that you can be on the same page. Okay. At some point, if you feel you don't get me anymore, just let me know so that we can come back to discuss.
Okay.
All right, so let's put the grid line modeling. I believe that all these ones, it should not be new to you. Just a way of refreshing from where we stopped and then to build up correctly this time around. So this is 1A. The next one is 1. And the next one is 2, 3, 4, 2, 3, 4, 5, 6, 7, 8.
So there was one thing I observed those other architectural plans were sending me. I don't know whether it's from the architect. The end of the day, the column placement are not always symmetrical to the last floor.
To the last floor.
Yes.
You mean in the previous one I sent to you?
Yes, it was kind of complicated,
Act-
especially the last.
I was expecting you to say that actually. The whole arrangement on the upper floor changed. It doesn't actually look like what was coming, what we had on ground. I saw that too. The thing is that I designed that project you're talking about, and I noticed that, but I've been able to work around it, and that's exactly what I want you to also do because you are the engineer. That's one of the reasons they brought the project to you so that you can help them solve it. Because sometimes architects create problems they cannot solve, so they trust the engineer to help them solve it. So in that scenario, um, you just need to look for the best way out, like I did. So maybe when we're done with this project, we're going to take a look at scenarios like that where projects are complicated. Because you can't tell the architect that this thing is complicated, I can't do it. No, no, no. If I trust you to be able to undo it. All right, so let's move on there. Okay, so I have the vertical grid line. The horizontal grid line says A1, A1, A, A1, A, and then we will have B, then B1. So I can call this A to, I don't know, it depends on, you just call it A prime prime or something. Or I prefer if this would have been A prime, so that I can call the remaining two properly. So I can stretch this to come out and I change it to A prime. Then move it to one. All right, so we are done with that. So we want to insert our columns, just as we have done in our general arrangement, so that we can move on. We have columns all around the perimeter. Okay, 25 by 25 column. This, 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 and this. Okay, on this part. On the other part, we have the same thing. We have the same thing. So there's a same thing. This. All right. And we have one of them here. All right. So let me confirm if there another. Okay. So that's all. Next is the beam. So let's go for the beam. We're using the 450 by 25 beam. So, and we have cantilevers roundabout. I'm drawing that as a continuous beam. I'm doing this also as a continuous. Okay, so I have this. I have this. And this. And this. Is a complete piece. And this. I have this too. The beauty of this part is that you must understand primary and secondary beam so that you won't make a mistake that affects your building analysis. I hope you understand what I mean by that.
You said?
I said that the beauty of this part of this of modeling is that you must understand the primary and secondary beam so that you would not create a problem during the building analysis. I have a video like that on my channel. for when I spoke to you primary and secondary beam. So now that we have done the beams, how about the slab? So we can just use the 150 mm slab. Sorry, this is go back to modeling. Slab. Thickness is 150. The concrete cover is 20. Then the load room, or we want to use the usual 1.2, 1.5 finishes partition, 1.2, that's 2.7. We want to use that, you can do that. Or in post load, you just want to go for domestic residential floors. 1.5 is the minimum and 2.0 is the maximum. So I think 1.5 is good for us. So and go ahead and use all of this into the necessary program.
So like
What
liver beans. Is it also possible not to use liver beans? There's this technology.
is it
Can
possible
you,
not to what?
like in your own GA now, you added cantilever beans. You also can another social engineer decide to use cantilever beans too.
Yes,
What I ask us.
if he has a way of supporting the upper floor without columns. Because the reason for my cantilever beam is because all these columns you are seeing presently, majority of them are stopping at this floor, not going to the roof. And I want to support my roof beams. So I'm trying to devise a means around that. That's why I'm using this option. So if there's a way of going around that without this, why not? It's free. So after this, we're going to do the roof because this is the first floor. We're going to do the roof. Then we analyze our model and check for the result. Okay, so this is it. Now let's put in our roof. So because I need one more story here to create that, I right click on story, insert story. I'm in need of the second one. Okay, and that's it. So the structure is a story. Let's take it as 3 meters each. So I want to call the first floor, the story one floor, first floor, and the story two, roof. Good. So to bring my GA to this floor, what I do, I go back to building setup, go back to external reference point, change the story to 2, and it becomes visible. Then I move the new GA that I need to be in alignment with the previous one that I just used. And I press OK. So this is what I have. This is the roof beams now. So what I need to do is to now look at this. You see these columns here? Look at where they are on the roof. These columns are getting out here on the roof. So let me just put them there. Modeling 25 by 25. This. Which one else? Now look at this part. This column is not here anymore. That column is not here anymore. All right. So we have other columns too, like this, like this. So I want you to do the GA and let me see how you come about your own solution for supporting the structure. Because always sometimes it's quite different. Two people can solve a particular problem differently, and they will both be right. That's one beautiful thing about engineering. It's just a matter of perspective. So it happens that on the roof, we have roof gutter. I don't know whether you can see that, you observe that this
Let me see. Okay.
this is the roof slab now. So that's the slab. So let's make that visible in our product structure because it's part of the details that we need. So let's fix our beams. Let's fix our beams quickly. Modeling beams. So we go like this because this forms the primary beam now. And different from the other case scenario. So you need to understand this concept I've been talking about. Now look at this, what's going on here? So it means this one is wrong. If I do it this way, it's wrong. So I use Ctrl Z. Then I have my beam. This one has to go first. One has to go first. And then hold on to this. I'm trying to check. I'm trying to check. Okay. So this one goes. This one also goes like this. This one also goes like this. This also goes like this. This also goes like this. Even this. And then behind like this. This goes like this. Then this one can come like this. So you have to be strategic in placement. I mean, placing these things. Yes, it comes down in here. This one comes down. This one goes all the way down. Yes. And then this one can come. Now the roof gets here and not the other way. It gets here, so this one gets out. All right. So and this one comes out. Okay, so as it is now, we are just left with the beam. Now, but look at the size of our beam. It's not correct on this floor. So we need to correct that. And we can't be doing it one after another. So to do that, we could go back to your beam, right click, beam table, then click on the thickness column. So for column wise edit, once you right click, you can change that to maybe 375 or 300, whatever it is that you want to scroll. Then we can now place our slab. Now this slab, I want it to be a downstand kind of slab in the sense that it sits below the slab and below the beam. I mean, just at the soffit of the beam. So we have the the depth is 375. The depth of our slab is 120. So that's about what's going to be that difference? 375 minus 120. That's 255. So what you just need to do is to put at the reduced level, let's go there, put 225. And 255, not 225. It's supposed to be 255. So here you can put flat roof or the imposed load as you want, maybe 1.7 or so, because it's at the roof. But that this was unique to you, whoever it is you want to apply. So let's check for the 3D and see what's going on there. 3D physical model. So I want us to confirm how this slab sits in the arrangement. Now look at it, it's floating. So to stop it from floating, let's get back to property. So the reduced level is supposed to be minus so that it goes down. So if you look at it, it's not really sitting well because I said it is 255, not 225. So when we update it, it sits very well, correctly. So we're done on that part. So let's fix in other ones. Other slabs. We have that let's go back to the plan. If you on the plan, then the 3D. Okay, let's fix another one. This, 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 and we have this. Good. All right, so now that we've done that, the rest are there. I think we're good on all sides. Let's on the first floor, we're supposed to have walls. So if we have 3 meters floor height and we have 375 roof beams, it means that the height of our wall is supposed to be 2625. So what you do is to right click on any of this beam on the first floor and edit wall load. Edit wall load. Once it opens, the unit weight of the block wall, 9 inches block wall, 28.87. The wall height, like I said, 2.625. Then the thickness of the wall is 225. All right, so we're good. Once you click that, it appears on that as in this color. So you copy the wall load,
Can you go over that again?
the wall load, right?
Yeah.
Right click on any beam, edit wall load is the option. The unit weight of a 9 inches block wall, which we are using, 2.87. The wall height is 2.625. How did I get that? The floor height is 3 meters, and then we have the beam above it to be 375. So I subtracted 375 from 3 meters, and that leaves us with 2.625. Then the thickness of the wall is 225. So that's how we came about that. So once you're done, press OK and right click again to copy the wall load. What I want to do by copying is to paste on all the beams on this floor. So I hold down my shift control, clicking the first and the last beam from that row, highlight everything. right clicking, and I press paste copy with wall load. Yes. So you can see that I pasted this successfully. All right. If you want to also cater for maybe a portion of the load from the roof, you just want it to feature around this on the beams. Maybe you can just put a 1 meter high wall or something. So just to cater for the roof, 2.87, 1 meter high, and then 225 mm thick. All right. So once you do that, you change this color, copy wall load rather. Do the same, click the first one, hold down your control key, and click the last one. Then you can paste, copy beam wall load. Once you do that, our model is complete. At least for now, we should have something like this. Should have something like this. Okay, that's what we should have. Now, the next thing we want to do is to do our building analysis.